So in this lab, solutions, colloids, and suspensions, what we want to do is figure out which substances can cross a cell membrane. And we're going to use cellophane to mimic the walls of a cell. The substances we're going to be testing for are going to be chloride ion, starch, and glucose. And in order to test those, we're going to perform different chemical tests. We're going to have the cellophane bag with our different solutions into a beaker of water, and we'll test the water in that beaker to see which ones actually crossed from the cellophane bag into the beaker. Okay. But in order to figure out what a positive test look like, we're going to be running some control experiments. So that will be part A. We're actually going to get everything set up for part B first and then come back to the control test. But let's talk about what they are. So we want to be able to know what a positive and negative chloride test looks like, positive and negative starch test, and a positive and negative glucose test. Because later on, when we go ahead and test our solution in our beaker, if we get a positive test, that tells us that that particular substance was allowed to go from the cellophane bag and cross what we mimic as our cell membrane into the solution around it. Okay, so what we're going to do is we're going to set up these 3 different control tests. For each one, you're going to have 2 different test tubes. So in the first one, we're purposely putting in the chloride ion. We know that sodium chloride breaks down into sodium ion and chloride ion when we put it into water. So we know that will be our positive test. We're purposely putting it in there. And our control negative test will just be water because it has no chloride ions. So you'll have those 2 different, sodium chloride solution in one test tube, water in another test tube, and you're going to add silver nitrate to both to see what happens. So this way you'll know what a positive test looks like, and you'll also know what a negative test looks like. For the second one, it will be the starch test. So for our positive control, we're going to purposely put starch solution in there. So that will be a positive test. We'll know what it looks like. And for our control negative, again, we'll use water. You're going to add iodine to both. Make sure you make good observations, record in as much detail as you can about what happens. So that way we know what a positive and negative test looks like. For the last one, the glucose test. One test tube will have glucose. For your positive test, we're purposely putting it in there. And then your negative test will just be water. We're going to add Benedict's reagent to both, and you're going to heat it up in a hot water bath, just like we've done before. So we have some experience with the Benedict's test for oxidation. Okay. For part B, we're actually going to set this up first before we go back to our control experiments, because we can run these chemical tests side by side with the control experiments. That is fine. So what I want you to do is start with part B. Okay. I would have one person go ahead and start a hot water bath. This is not for your cellophane bag, This is going to be only for your Benedict's test. Your cellophane bag will go into just a beaker of room temperature water. It has to be deionized. So what we're doing in part B is we are actually going to go ahead and test which substances can pass through the cell membrane, our cellophane bag, and go into the beaker of water surrounding it. And we're going to compare the chemical test from our controls in part A to figure out whether we have a positive test, so that means yes, that substance can pass through the cellophane bag or our cell membrane, or a negative test, meaning no, that particular substance is not allowed to pass. So I would have one person start with getting the dialysis bag ready. The dialysis bag is going to be the same as our cellophane bag, and I'd have the other person go ahead and start on the hot water bath. Okay, what we need to do first is make our solution for the cellophane bag. So you're going to take a beaker. Doesn't matter exactly how big it is, but one of your smaller ones, and you're going to add 10 milliliters of the sodium chloride solution, 10 milliliters of your starch solution, and 10 milliliters of your glucose solution. From here, you want to make sure you mix everything so everything is dissolved. We have equal distribution. And you're going to transfer only 20 milliliters of this to your cellophane bag. So the cellophane material will be out. You want to cut 8 inches of the material. In order for you to be able to open it, you have to wet the cellophane bag, and you want to make sure you do this in deionized water, because if we use tap water, remember that it has other ions in it, and that could interfere with our chemical test. So you're going to cut 8 inches, wet it with water. You're going to clip one end, so the clips will be out, and then you're going to take 20 milliliters from your beaker that you just made, only 20, transfer it in, and then you can add a clip to the other end. Okay, I would move it back and forth a few times to make sure it's tight. Otherwise, you'll have leaks and you'll get false positive test when you do the chemical test. So this part you want to get set up as soon as possible because your time starts here. So as soon as we have that, you want to immediately put it into a 250 milliliter beaker, and you want to cover it with deionized water. So again, make sure it's deionized. From here, you want to immediately take out 15 milliliters. Okay, so we're going to see what can immediately cross the cellophane paper or the cell membrane. So from here, you're going to divide that 15 milliliters into 3 different test tubes. So 5 milliliters in each. And what you want to do is now perform each of the chemical tests. All right, so make sure, for example, the chloride test, you're not adding in sodium chloride, right? Because that will definitely give a positive test. We want to see if the chloride actually crossed the cellophane. So from here, the only thing you would have to add is the silver nitrate, so only the reagent used to test. For the starch test, we don't have to add in the starch solution. We're testing to see if it's actually in here. So for that, we just want to add the iodine. And for the glucose test, you'll just add the Benedict's reagent and go ahead and heat it up in the hot water bath. What I would do is, once you get to this step, I would also run your control experiments from part A side by side. That way you can do them both at the same time and you have a fair comparison. So make sure you start your timer as soon as you drop the cellophane in, okay? After 20 minutes, you're going to do the same thing. So we want to see what's allowed to cross over time. So you're going to remove another 15 milliliters at 20 minutes. You're going to divide that into 3 test tubes like you did before, so 5 milliliters each, and you're going to perform the same test. So for the first one, you'll add in your silver chloride, or silver nitrate rather, to do the chloride test. You'll add in the iodine to the second test tube to do your starch test. You'll add your Benedict's reagent to the third, and you'll go ahead and put that in the hot water bath, and make sure you're just recording your observations. The next time slot is going to be 40 minutes from the time you started. You'll take another 15 milliliters out, again divide it into 3 test tubes, and you'll perform each of your 3 tests. Right? For the very last one, so after you've done your 40-minute test, you can go ahead and break the cellophane. Okay, so all the solution will go out. So this tells us that now we have all 3 substances in there. We should get positive tests for this one, but we're going to test it anyway. So once you break the bag, you'll take 15 milliliters again. You can just take it out of the beaker and put 5 milliliters in each test tube, perform the same test. So once we've done all of that, we want to compare each set of times that we remove some of the solution. Okay, so after each time slot, we want to compare all of these to the control test. Right? Again, if we get a positive test, meaning that what I see looks very similar to what I saw for the control test as a positive, that means that that particular ion or that particular compound is allowed to cross the cellophane or our cell membrane. So we want to make sure we compare to that.